Hey guys, I'm just going to do a quick video on the more complicated parts of factoring. We're going to start with the differences of cubes. So just a few rules here. I'm not going to go through all of them, but I'll go through the first one. A difference of cubes is two expressions which are both cubes, and either addition or subtraction is separating them. So an example of that is x cubed minus y cubed and 27x cubed plus y cubed. So we're going to use the example of x cubed minus y cubed. So your polynomials should be multiplied, so you're going to have this is going to go to two polynomials, clearly, and then I'm not going to go through all these rules, we'll go through those in the video, and then at the end, you should multiply your two polynomials to get something looking like this. Okay, so we're going to start with an example. So x cubed minus y cubed. So we're going to start with the cube root of x cubed and the cube root of y cubed. So this is the first thing that you should always do when working with cube root expressions. So this is going to equal x, obviously, and this is going to equal y. So we're going to start by taking the cube root of each one and just creating our first expression to be multiplied, which is our first binomial. So we're always going to take the cube root of the first and last expression and put them in here, and then the symbol that separates them is whatever symbol is here. So then for our second one, it's a trinomial. So the weird thing about this is that we're actually going to take whatever we cube rooted first, and we're going to square that. So if this is x, up here, it's going to become x squared. And if this is y, at the end, it's going to become y squared. But then we still have something in the center. So the thing that goes in the center is the x and the y multiplied together. So we're going to put an xy in the center. And then we're just going to add addition all around because we already have the subtraction. So whatever's in the first expression needs to be the opposite in the second expression. So that seems a little bit confusing right now, but we're just going to try another example so that it becomes less confusing. So first, with this expression, we're going to take out a 4x. So we're going to do 4x times x cubed plus 8y cubed. And now we can recognize that this expression right here is a difference of cubes, and that can be with addition or subtraction, it doesn't matter. But this time, since it is addition, it's going to look a little different. So first, we're going to find the cube root of x cubed, which we already found is x, and the cube root of 8y cubed is just going to become 2y. So we put that into our first expression, so we have x, and then since this is a plus sign, we have x plus 2y. And then for our second expression, we square this x, so it becomes x squared, and then we have something here, and then we are going to square the 2y, so this is going to become 4y squared. We have to make sure to square the whole expression, and then we're just going to multiply these two together, so that becomes 2xy, and then because we already have an addition here and here, we're just going to add a subtraction here, so this becomes your total expression. So that's a little bit on cubics and difference of cubes and that kind of thing. So I hope that makes sense. Okay, next we're going to work with recognizing differences of squares. So this polynomial looks very complicated and looks like it can't be factored. However, it can. First, we need to look to see if there's an xy term. So because there's this term, we know that this a is not going to be used in this order. And we know that the 16y needs to move over here. So first, I'm just going to rewrite this expression. 9x squared minus 24xy plus 16y squared. And this is because I know the x and y are going to multiply together to create this, so those need to be next to each other. And then at the end, we're going to add the minus 24a squared, but for now, we're just going to focus on this portion right here. Okay, so now with this portion that I just underlined, we can see that this is actually, this can be factored, become 3x minus 4y squared, right? So that's just simple factoring. And then we still have this minus 25a squared. So most people think that this is where it finishes, but this actually isn't where it finishes. So because there's the minus 25a here, this actually becomes another difference of squares. So first we're just going to take this expression and we're going to substitute it for m. So we're going to do m equals 3x plus 4y. And we're just going to say m squared minus 25a squared. Now, this can be factored super easily. We just have m minus 5a times m plus 5a And as we know about difference of cubes, these are going to cancel out to become m squared minus 25a squared. But now we still need to substitute these values back in for m. So now we do 3x plus 4y minus 5a times 3x plus 4y plus 5a. And this is our final expression. So that's just a little bit on recognizing differences of squares and how to apply it to different situations. So we're just going to try another example. This one's a little different. So for this one, we have to recognize that these are two separate groupings right now. So there's no way to factor this whole thing easily. So if we split it up and we can see if there are any terms that can come out of each expression. So for this term, we see there's a common factor of x squared. So we're going to take x squared times 5x plus 2. Now for this, there are a lot of common factors, but we want to get it to look like this, 5x plus 2. So we can see that a negative 9 can come out of both of these factors and give us minus 9 times 5x plus 2. So now this becomes our expression, and this is actually, we can combine these terms. So because these both have a 5x minus 2, we're just going to take a 5x plus 2, and we're going to take that out of both of these expressions, and that leaves us with x squared minus 9. So that means that we're taking this out and we're taking this out, and we're just leaving the x squared and the minus 9. Now this is another difference of cubes. So we're going to have 5x plus 2 times x minus 3 times x plus 3. So then this difference of squares gives us this, and this is our final expression. Okay, we have another example. So in this example, we need to find out what needs to be grouped together. So I see we have an x and a y here, right? An x, and then we need a y. So we're probably going to need this 16y squared. And then I'm going to guess that this 5x and this 20y can be grouped together. And then this negative 6 is going to have to be grouped separately. So we'll see where that takes us. So first I'm just going to start by rewriting these. X squared plus 8xy plus 16y squared. We're just going to group those all together. And then I'm going to take the 5x, add 5x plus 20y, and we're going to group those together. And then at the end we have this minus 6 that we don't really know what to do with yet. So starting with the blue, we can see that this can be factored to become x plus 4 squared. Now this red, there's a common GCF of 5. So you can take out a plus 5 times x plus 4y, and then we still have this minus 6. So at this point, the important thing to recognize is that we have a common factor or common thing of x plus 4. There should be a y here. X plus 4y. So this means that we can substitute something for this. So if I make m equal to x plus 4y, then I can just make it m squared plus 5m minus 6, and this becomes a simple factoring problem. So this is x plus 6 times m minus 1, right? But now we actually have to bring the m back in, so it becomes x plus 4y plus 6 times x plus 4y minus 1. So I hope that makes sense. That's it for the video. Just recognizing differences of squares and knowing how to factor differences of cubes, that's really important for this unit.